Hello class, welcome to our studies on polynomial functions. Today we are particularly going to study about the introduction to polynomial functions, where we will deal with the understanding the basis of polynomial function. Now let's look at what a polynomial function is. First of all, let's look at the definition. A polynomial function is an algebraic expression involving the sum of terms consisting of variables raised to non-negative integer powers multiplied by coefficient. So generally, polynomial function is being expressed as this, as you see here. That is p of x equal to a subscript n x power n plus a subscript n minus 1 x power n minus 1 plus a n minus 2 x power n minus 2 plus up to a power a subscript 1x plus a naught, where an minus 1, an minus 2, a1 and a naught are constant. They are the constant term. That is the reason why we are saying that there is an unknown variable x or a known variable raised to the power of positive integer, that is positive index, that are all integers, which is being multiplied by coefficient. And we have n minus 1, n minus 2, 1, 0 are all non-negative integers. And as I said, it is an algebraic expression, and any algebraic expression contains a variable which is an unknown variable x in this particular polynomial generalization. So let's see an examples of polynomial functions. We have polynomial examples here. That is f of x equal to 2x power 4 plus 3x squared plus 5x squared minus 6x plus 7. When you look at this particular example, you are going to realize that x, the variable, is raised to the power positive integers. And the indices, all the indices are positive. And it is positive and it's supposed to be integer, not a fraction, not any other number, but except an integer. What are integers? Integers are positive and negative whole numbers, but we are talking about the positive whole numbers. So here we also have g of x equal to 2x plus 3. Here the power is 1, not negative. We also have h of x equal to x power 4 minus 3x. Here the power is 4, not negative. And f of x equal to 5x plus 4x squared minus x plus 7. It has been arranged in order, and the highest power, the power is 3, the power is 2, the power here is 1. So you can realize that the power for the variables in each particular term is a positive integer. So let's look at this particular polynomial examples here. We have 3x power negative 2. The negative 2 make the whole expression not qualified to be a polynomial function. Why? Because for a polynomial function, the exponent of the variable is supposed not to be negative. And here too, we have f of x equal to root x plus 2. Here too, the power is 1 over 2, that is half root. And it doesn't qualify to be a polynomial function because it is not an integer. 1 over 2 is rather a fraction, not a positive integer. So we are on terms and coefficients. Here, what is the meaning of the terms in polynomial expression of function? A term is part of an algebraic expression separated by plus or minus sign. So when you see plus or minus sign in between expressions, it means that the expression the separate expressions are being graded or maybe represented as terms. So look at here. We have 2x power 4 plus 8x squared minus 6x plus 7. We have the examples at this particular section. So when you look at this particular section here, 2x power 4 and 8x squared are being separated by addition. So they are separate terms. So this is a separate term, this one too is a separate term, this one too is a separate term, this one too is a separate term. So if you are being asked how many terms do we have here, it means we are having 1, 2, 3, 4 terms. And these terms have been arranged in order, which means that we have a leading term and the last term. So the leading term is the one with the power with the variable raised to the power of higher index. So here we have 2x power 4 being the leading term, and we have the constant term here. So here the terms are the expression being separated by addition and subtraction. The coefficient are the numerical factor in each term. So what we need to understand here is such that when you come to this particular diagram, we have the 2x power 4 as squared minus 6x plus 7. These are the coefficient. They are the values or the numbers multiplying the variables. So we have the 2, 8 minus 6 being the coefficient. Then we also have the x being the variable. We also have the 7 being the constant. So here we also have the monomial, which is 2s4, the 2s power 4. It means that if you take only the first term, we call it monomial. When you combine the two terms, you call it binomial. When you combine the three terms, you call it trinomial, as you can see from this particular diagram. So we need to understand the terms and the coefficient of this particular studies on polynomial expression, and the terms will help us understand the concept in its best form. Let's look at the degree of a polynomial. The degree of polynomial is the highest power, that is the highest exponent of the variable in the polynomial. Example, we have f of x equal to 2x power 4 plus 3x squared plus 5x squared minus 6x plus 7. Here, when you look at this particular polynomial function, the highest powers of the x is power 4, so the degree is 4. Look at this one, the highest powers of the x is 1, so the degree is 1. The highest powers of the x is power 4, so the degree is 4. The highest powers of x here is power 3, so the degree is 3. That is how we can define and identify the degree of a polynomial function. That is the highest powers of x. Let's have a look on how we classify polynomial functions. So we are on classification of polynomials. We classified polynomials based on the number of terms or the degree of the polynomial. So if we have only one term for the polynomial, then we call it monomial. 2 term will be binomial. 3 term will be trinomial, as you see here. So monomial means that we have a single term for the polynomial. Binomial means that we have a double term for the polynomial, and the trinomial means that we have 3 terms for the polynomial. Then classification can also be done by or in the form of their degree. So we have the constant polynomial, that the degree is 0. The linear polynomial, the degree is 1. The quadratic polynomial, the degree is 2. Cubic polynomial, degree 3. Quartic polynomial, degree 4. Quintic polynomial, degree 5, because a polynomial is also classified by its degree, that is the highest power. So the degree of the polynomial is based on its highest power. And the classification of polynomials are the ones that identifies the type of polynomials we are dealing with or working with. Let's go to the polynomial types here. So here we have a table identifying the polynomials, their degree, and a type. So we have the constant term here, f of x equal to c. Example, we have y equal to 2, y equal to minus 4, y equal to 2 on 3. That means that this polynomial is having only a constant term. We have linear term, is also of the form f of f equal to ax plus b, where a cannot be 0. The moment a becomes 0, it becomes a constant term. So here we have f of x equal to minus 2x plus 3, y equal to 3x minus 4, x minus 2y equal to 4. All these are polynomial of degree 1, which the name is linear. Then we have the quadratic, which is ax squared plus bx plus c, where a cannot be equal to 0. The moment a becomes 0, it ceases to be quadratic and becomes linear. So the example is f of x equal to 2x squared minus 4x plus 3. We have the cubic, that is the degree is power. The degree is 3 because the highest variable is the highest index of the variable is 3. So we have f of x equal to ask plus bs squared plus cs plus d. And the example is what we have here. Then we have the quantic and the quartic and the quantic. The quartic is the polynomial of degree 4, and the quantic is polynomial of degree 5. We have these examples to represent the quartic and these examples to represent the quintic. So let's go to classifying polynomials. So here we have polynomial classification here. When look at this particular polynomial, it is trinomial, but the degree is 3. Look at this particular polynomial, it is binomial, but the degree is 4 because the highest powers of the known variable x is 4. So we have the polynomial monomial and the degree is 1, and we have the monomial degree is 0. Monomial means the term is only 1. Then let's go to evaluating polynomial function. How do we evaluate polynomial function? We have this idea already from the evaluating of functions. So it means that the input is x, then output will be gotten from the processing of this particular function. So when you input 1 into this particular function, it will process everything based on the rules of the function for us to get the output, which is 19. It means that anywhere we see x, we substitute 1 into the expression. Good. Let's look at the graphical representation of polynomial function. So this one is when the degree is 1, that is linear. This one is when the degree is 2, that is quadratic in the form of parabola. This one is when the degree is 3, that is taking this curve-like shape. It rises and also falls. So when it is linear, it is a straight line. When it is quadratic, it is a parabolic curve. It can be in the form of this, the U or the N shape. When it is cubic, it also takes this form. So these are the representation of polynomial functions. Good. Then we can also note about the importance of polynomial function in practical, in real life application. We use it in modeling economic growth, in physics, that is projectile motion, and engineering. We can also use it in engineering, that is the stress strain analysis. And we also have to understand these practical questions. Consider the polynomial function this. What is the degree of this particular polynomial function? So you have to tell me the degree of this particular polynomial function. What is the leading coefficient of the polynomial function? Let me give you the clue. The leading coefficient is the term with the highest powers of x. Then they are also asking you to evaluate the polynomial p of 1. It means that when the input is 1, what to be the output for this particular input 1 whenever you inputted the 1 into this particular polynomial function. The summary of this our studies is on the definition, terms and degree, classification and examples, and I know you've learned a lot from this particular studies on the introduction of polynomial function. Don't forget to subscribe to Roland High School Math Room, where we make maths education very simple and understanding. You can send me your feedback through this particular email or this particular WhatsApp number or through this particular channel, and I'll be ready to receive them to help you understand the concept of high school mathematics. Thank you.